Hey, welcome back to the Fusion 360 for Woodworkers course. This episode I want to look at those cross shelves, but before we do that I want to talk to you about properties and how we can turn our material from the grey slabs that we've worked with so far to something that actually looks a little bit more like wood. That sounds good? Stick around. So here we are back in Fusion 360. Last episode we got to this point. We've got these internal panels done and we've got everything joined together using some pretty nice and special dovetail joints. Looking really good. Now so far everything inside our world has been these grey slabs. And if you remember back to episode 2 I think it was, I was talking about the difference between components and bodies, and how a body is just a dumb 3D representation, whereas a component's got some intelligence inside it. And I compared the two, and I was talking a little bit about think of a body as your raw stock, think of a component as your finished surface. Now these are all the components we have down here on the left hand side, and if I look at the base panel, and if I right click on the base panel, I can come down to this properties here. And clicking on properties brings up this menu. And you can see I can give this a unique part number, which is great when we're creating our cut lists. I can give it a part name, it's called base panel, it just inherits the name from the component. I can give it a description, but now it also starts to tell me a little bit about the material I use. And as you can see here, my physical material is actually steel. Now steel is a default position for Fusion 360, so everything you create when you start out is steel by default, and that gives me the area, the density, the mass, the volume, all on physical material of steel. Now we can change the material that we want to use. And come up again to your component, right click on that component, and coming down you can now see I've got this physical material. So highlight that, and that brings up this menu, and by default you've got ceramic, electronics, fabric, flooring, glass, gas, liquid, metal, miscellaneous, plastic, stone and wood. So if we click on the wood, inside wood we've got ash, birch, cherry, Douglas fir, Jara, laminated veneer, Meranti, MDF, mahogany, maple, oak red, oak white, OSB, particle board, pine, different types of pine, plywoods, etc. And we can actually tell Fusion what the material is. So I'm just going to come in and just use a standard pine. And I'm going to drag that pine and drop it onto the panel. And straight away you can now see that my base panel is now made out of pine. And if I right click on the base panel again and I come into properties, you can see that my component instance has now changed. And the area and the density and the mass and the volume have changed because my physical material is now pine. So we can create the materials we're going to use in our bookcase as we go. Now I find it easier, as I create a component, I then set the properties for that component. So my base panel is the first thing I'm going to make, so I'm going to call that part 001. Base panel is the right name, although I could change that here. And the description, now what I tend to put in the description are the overall dimensions, and when we get to drawings further down the line it will use that description in our cut list to tell us the size of the part that we need to make. This bounding box, if you highlight that, it actually gives you the dimension of your stock. So I can come in here and say, well, my length is 2352 millimeters, my width from front to back is 265 millimeters, and my thickness is 80 millimeters, and that will then pull that information through. Just to complete the activity, the world XYZ, remember the origin point 000, this shows me that the base panel is anchored at that origin point. Center of mass, it tells me about that, it gives me details about moment of inertia, details of moment of inertia of the origin, so on and so forth. And all this information is used by Fusion if you want to start to do stress calculations on your project. We're not going to look at that this time around, but you can see the intelligence that sits inside a component as opposed to a body, which is just a dumb 3D picture. Now let's turn our attention to the side panels, and as you can see when I highlight the side panels, both the left and the right highlight. Now that's because we made those two panels at the same time. And as you can see here, there's only one side panel. If I look inside the side panel, look inside the bodies, I've got two sketches, which are the two different sketches that we made, but I've only got one component. So Fusion treats these two pieces of our bookcase as one part. So if I look at the properties inside the side panel and look at our menu, again, we know that it's steel, although we'll change that in a minute. But look at the bounding box. It's got a length of 2352, and that's the same length as the base panel. So it thinks that these are actually 2352 long from the left-hand corner over here to the right-hand corner over here. The width 265 front to back is correct, and the height 1180 is also correct. But this 2352 should really be 18 millimeters. So what's happened here? That's because when we extruded them both at the same time, and therefore we created a single component. Now that's no good for us, and that's going to confuse our cut lists and our drawings further down the line. So I want to change that back to be separate components. And I want to show you how you can use the history tree down here to make that change. Now all these parts here are all those changes that we made over time. Remember, we use the combine command on the base panel to cut out the sliding dovetails. We use the combine command on the top panel to cut out the sliding dovetails. We extruded the internal panel to their overall height, and just hovering over any of these icons tells you what you did. And if you come all the way to the left, this icon was where we extruded the side panels. That's what I want to change. So I'm going to take my lollipop and I'm going to slide it all the way back to just before I extruded that. And as you can see, everything else is gone. Now by default, when you use a sketch, Fusion will then go ahead and hide that sketch so you don't see it again. But you can bring it back. And if I look inside the sketches, you can see my different sketches that we made are all here. It's remembered the sketches that we made. This one here in sketch 4 were those end panels. So I've simply turned the sketch back on. Now what I can do is to come in, zoom in to one of those end parts there, use my extrusion command, press pull at the top here, highlight the face, and now I can start to extrude that up. Once again, we know that this distance wants to be the bookcase height. Remember, it was minus the stock thickness, okay, and we want to make a new component. Now, when I click OK, watch your side panel here, and then have a look at the history down here. Okay, now look at that, it's made a new component there, and it's given me a new activity inside our timeline, which is where we extruded that component number 8, that component, and that component. If I now give this a name and call it left panel, return, you can see now it's picked up that name, that's where I extruded the left panel. I'm still in the timeline and I want to go to the other end. So I select the push pull tool, I select the face I want to extrude that up. We use bookcase height, we use minus the stock thickness, I come in and I create a new component from that, and when I press OK, I have another new component, and we're going to call that component right panel. And down here you can see it's created this new component right panel. Now that double extrusion we did still exists here in the timeline, and I'm going to select that now, and I'm going to hit delete. And now when I come back in time to the modern day, dunk, you can see I've now got the panel that we actually need. And here I've now got my left panel and I've got my right panel. Delete the components up here, we no longer need that one for those side panels. That's then gone. And that's it. And we're back to where we should be. So if I now come into the left panel, look at the properties, you can now see my bounding box. I've got 18mm, 265, 118, which is perfect. So my left panel is going to be 002. My description is going to be length is 1180 multiplied by the width that we know is 265 multiplied by the thickness that we know is 18. Okay, now once again I want to make this pine, so I can come down to the physical material. It remembers what I did last time, so it puts the pine in my quick menu, and I can turn that into pine. And in fact, while I'm here, I can turn everything into pine. And you see how all those turn to pine at the same time? That's because they were copies, remember? Turn this end panel because it's now unique, and the top panel. Now everything is now pine inside our bookcase. So as I create a component, as we said earlier on, I always design as I build. So I make the base panel, then I make the left panel. My third activity, properties, this is going to be 003. It's going to have the dimensions of length is going to be 1180, the width is going to be 265, and the thickness is 18. Now depending how you draw that, these lengths, widths and heights here don't always make sense. So look at the numbers and then put the correct information here. This will appear on your drawings and cut list, this information won't. We'll then do the top panel quickly, same technique. That's going to be piece 004. The description of this one is going to be length is 2352. The width is going to be 265, and the thickness again is 18 millimeters. Now these internal panels are all copies of each other. So if I click on my internal panel and come to properties, let's call this piece, was it 005. My bounding box size is going to be a length of 1192 multiplied by a width of 265 multiplied by a thickness of 18. Now when I click OK, it will update the properties for all of these. So if I come to panel 5, properties, you can see it's already had the information in. And because that's a copy part, just having a part number 005, but 4 instances of that is exactly what you'd want to see in your cut list. So we're in good shape. So just to recap what we did there, we used the timeline to come back in time to change a mistake that we made. And you can see the entire model auto updated, and we still got those parameters that we modeled driving the overall bookcase. We then defined these as a certain material type, and in our case pine, and we can now see that's appearing here. We then updated the properties, so each of these have now got some clear information inside that we're going to use to drive drawings further down the line. Now if you look at our tree on the left hand side here, it's beginning to get a little bit messy. Internal panel, internal panel, internal panel, internal panel. And to be honest, I would just build these as a sub-assembly. I'd come through, make all my internal panels, get the joinery cut on those, and then assemble the final thing. So I want to do the same here. I'm going to turn these into a sub-assembly. I'm going to come up to the bookcase design at the top, and I'm going to right click on that, and the top menu here, new component. I can just create an empty component, and that's what I'm going to do, new component. And I look inside here, all it's got is the origin, which is our normal origin. There's nothing else inside that component. Let's give this a name. I'm going to call this internal panel sub-assembly. Ooh, I like names like that. Now I can drag these from here onto there. 1, 2, 3, 4. So you can see the icons change from that square cube to a couple of square cubes, and that shows me that I've now got things inside there. They're still components. I've still got all the information you'd expect to see, the origin of the component, the bodies of the component, the body itself, all sitting inside there. But now I can treat that as a sub-assembly, so I can turn that off and turn that on. And when I come to do the drawings, we can just do a internal panel sub-assembly drawing, which makes perfect sense for us. Now look at this though, these are now highlighted, but the outside case is sort of kind of gone faint. Look at this little radio button at the end here. That's the selected component. If you come to the bookcase design, which is the one that holds everything, and I click on that component, everything now comes back and it's all good to go. So happy days. Final thing I want to do for today is to drop in this set of drawer dividers here. If you look at our master diagram, that's this row of shelves here. Now I can come through and I can model each individual shelf and put it in the appropriate position and set up the dimensions, or I can cheat, and I'm going to cheat. So what I'm going to do here is I'm going to create one big shelf all the way across. I'll then use the modify tool that we've seen before to make individual shelves that will come out as bodies. I'll then turn those bodies into components, and I'll end up with a new sub-assembly here that will be that drawer divider. So let's look how I'm going to do that. I'm going to start by doing a sketch, and I'm going to sketch on this end panel here. I'm then going to create a rectangle, and I'm going to find this edge here. Do you see how that turns to a blue cross? That's because it's finding that edge, and similarly it can find that edge or that edge, anything we want. But I want this edge here, and I'm going to create a diagram that comes to that edge. Now the 85.3 now needs to change to stock thickness, and the top one we will just change to bookcase width. Now although we've defined the width and the thickness, we've not defined its position, and I want to define its position in relationship to this bottom panel. That there, that's our bottom panel, so that there is the top of our bottom panel, if that makes sense. So I'm going to come in with my constraint tool, sketch dimension, and I'm going to say that I want you to be constrained by that top panel. And let's give it a measurement. It's going to be the bookcase height, and I'm going to have the drawers always to be 1/8 of the bookcase height. So I divide that by 8. Bingo. And that's now set that for us, and you can see it's a defined parameter because it's got the FX against it. Let's finish that sketch. Now you can see at the far end of the bookcase there's that sketch. And I'm going to come in and I'm going to extrude it. And I just want to extrude that diagram that we've just made. And I'm going to extrude it all the way through. Now what I want it to be is a new component. I don't want it cutting through my boards. But the distance of this component, I want that to be the bookcase length, and I want to minus the stock thickness for the two end panels. So rather than typing minus stock thickness, I can now type in here minus open brackets stock thickness times 2 close brackets. So you can actually start to do some quite complicated formulas inside here, or expressions as they're called inside Fusion. So I've now got a shelf all the way across here. The problem is, of course, that's just one big solid piece of wood. And if I click on the component we've just made here and look at its properties and look at its bounding box, you can see the length is 23160, which is not a lot of good to us. So I want to break this up now into its component parts. Guess what we can use? We can use the combine modify tool. My target tool bodies are going to be these internal partitions, and my target body is that component we've just made. I want to cut it in half, and I want to keep the tools. Okay, bang. Now look inside the component, there was that shelf. Look what's happened. It's now created 1, 2, 3, 4, 5 bodies, and each of those bodies now represents a shelf. Now again, those bodies are dumb 3D representations of my shelf. They're not the shelves that I want. So I'm going to click on my body, right click on the body, and look at this, create components from bodies. If I click that, the body is now turned into a component. Inside there I've got my origin, and I've got the original body that we've just looked at. So I've got a component. So let's do that to all of these. Create component from body, create the components from bodies, create the components from bodies, and finally create the components from bodies. Now come back up to the first component we made, and let's give it a name. I'm going to call that draw divider sub assembly. and I'll call this one left, small left shelf. I'll call this one large left shelf. I'll call this one center, and large center shelf, large right shelf, and small right shelf. And now I've got another sub-assembly, keeping my tree nice and tidy here, and we've got what we needed. Now what's super exciting by this, and that super quick way of creating shelves, is it's all referenced against this end panel here. That's what we drew on. So all of this as a single component is referenced from that. I cut the component by referencing these. So as these change and the positions of these change relative to each other as we redimension, the cuts will change and these will automatically resize. Let's see that in action. Into my functions, my bookcase length, let's turn that into 3000. Bang! All those shelves have now updated in their size. And because I set a position of that relative to this bottom face, if I now come in and change my height, let's change that to 2000. Bang, that's all moved up by 1/8. So my proportions of my bookcase stay the same. I mean, that's silly because it doesn't look good, but that is still 1/8 of the overall height. And that's a super fast way of creating a sub-assembly. With that said, I think we've done enough for today. We've learned an awful lot. We've looked at the timeline and how we can go back in time to change our dimensions. We've looked at how we can create sub-assemblies to start to group things together, which makes sense from a design point of view when we create engineering drawings. And we looked at a super fast way of making multiple shelves, again inside a sub-assembly. I just want to come through and change the physical material of these pretty nicely, I think. Now the only problem with that technique that we've just used is each of these are individual components, so we need to go back in now and do the joinery on the end of each of these panels. Now the good news is we've not got to do it as we did it last time where we created each individual dovetail joint and sliding joint. I can create one instance of that and I can duplicate it as a feature across multiple areas, and we'll look at that in the next lesson. See you soon.